today we are going to solve this problem, arranging coins. LeetCode problem 441. Okay, so this is a binary search problem. So see, let's understand what's the problem wants. So you are given n coins and you need to arrange them in staircase pattern like this. So see, like this. Wait. So see, if we have n is equal to 5, so see, we are given n coins and we have to arrange them in staircase pattern. Okay, so like this, if 1 2 3 4, so like this. Okay, we have to arrange them. So see, in row 1 we need 1 coins, in row 2 we need 2, in row 3 we need 3 coins, in row 4 we need 4 coins. Okay, so and so on. So the question is, how many complete row can you make? So the complete means the row is totally full, like this. 1 has completed, 2 has completed, 3 has completed, like this. Okay, so see, if n is 5, so I start building a row. Okay, in row 1 we need 1 coins. Okay, we 5 minus 1 is 4. But in row 2 we need 2 coins, so 4 minus 2 is 2. But in row 3 we need 3 coins, but there has left only 2 coins, so we have just completed only 2 rows, so the answer is 2. Okay, see, so the answer is 2. Okay, because the third row is incomplete, we return true. Okay, so that's the question. Now let's take another example. If we have n is equal to 6, in row 1 need 1 coin. Okay, so the remaining coin is 5. In row 2 we need 2 coins, so the 5 minus 2 is 3. In row 3 we need 3 coins, 0 1. Okay, so in row 4 we need 4 coins, so we have only 0 coins, so the completed row is 3 1 2 3, so the answer is 3. We have completed only 3 row. Okay, in let's understand first brute force. See, we build row 1 by 1 and keep until coins finish. Okay, we count completed rows. Let me show you. If n is equal to 5, I have 5 coins, so in row 1 I need 1 coins. Do I have enough coins? 5 is greater than equal to 1, so yes, I use 1 coin, so the remaining coin is 4. I have used 1 coin, so the remaining coin is 4, so the 1 row is completed, so the count is equal to 1. So we move to the second row. In second row we need 2 coins, so do I have 4 is greater than or equal to 2? Yes, so in row 2 also completed. Okay, now count become 2. So now we move to, so 4 minus 2 2. Now we move to third row. Okay, so see, in row 3 we need 3 coins, but we have only 2 coins, so 2 is greater than equal to 3, so no, we stop, so the answer is 2. Now see, in brute force we need n is 5 and we need one variable row and count variable. Okay, so we check the condition. If n is greater than or equal to row, so it means 5 is greater than or equal to row. The first row is 1, we start from 1. Okay, so we enter in the loop, we do n is equal to n minus 1 means 5 minus 1, so we have used 1 coin, so count is equal to 0 plus 1. It was 1 row has completed, so the row is 1 plus 1, that was 2. Okay, we move to the next row. Now check, we check condition. N is greater than or equal to row, so 4 is greater than or equal to 2. We enter in loop, so n minus 2, sorry, 4 minus 2, that was 2, and 1 plus 1 2, it was count will increase, and row will also 2 plus 1, we go to the third row. Okay, now we check the condition. 2 is greater than or equal to 3, no, so we stop, so we return answer 2. Okay, that's it. But this code work, but if n is 1 billion, 1 billion means 1 0 0 0 0 0 0 0 0 0. Okay, we check 1 billion row one by one, so it was very slow. About time complexity of this is big O of n and space complexity is big O of 1. Okay, so can we do it better? Of course, because we use binary search idea. Okay, now let's optimize with binary search. Think about this. See, row go from 1 to n. Okay, the row is going from 1 to n means 1 2 3 4 5 in sorted way. So this is a sorted range. Okay, sorted range means binary search. Okay, binary search, we are going to use binary search. So see, instead of building row one by one like this, one by one, so pick the middle one. Okay, we pick middle one. We pick the middle one. Instead of building one by one, we just pick middle one and ask, can I complete mid row with n coins? If yes, maybe more row possible, we go to right. If no, too many slots, so we go left. Okay, so the formula, see, there is a formula. Okay, but check, but to check mid row I need a formula. Okay, so many coins the k row need. So row 1 1 coin, in row 2 there are 2 coins, in row 3 3 coins, so k is k coins. Okay, so total is 1 plus 2 plus 3 plus k, so on. If k is equal to 3, k is equal to 3 means 1 plus 2 plus 3, there was total is 6, but adding 1 by 1 is too slow, so we use this formula. Like, say, total is equal to k into, k is mid. Okay, mid into mid plus 1 divided by 2. So see how it's work. K means mid. Okay, k is equal to 3, we find our mid, we are just changing the variable name. Okay, k and 3 into 3 plus 1, 3 plus 1 4, 4 into 3, 4 into 3 is 12, and divided by 2, see 12 by 2, so the answer is 6. Okay, same 6. Where did this formula come from? See, so where did this formula come? Imagine we have 3 rows. Okay, let's change the color. We have 3, 1 1 2 3. Okay, if we flip, we flip it and put next to original, is look like this, 1 2 3. Together they make a rectangle. Okay, together they make a rectangle. So see, width is equal to k is equal to 3, and height is equal to k plus 1, that was 4, and rectangle, rectangle is k into 4, that was 12. Okay, so but we only need half. Okay, so we divide 12 by 2, 6. That's where k into k plus 1 divided by 2 come from. Okay, now see, now we try that in binary search. We use 2 pointer, left start from 1 and right start a5. So see, we find mid is equal to 1 plus 5 minus 1 divided by 2, that was 3. If we have numbers like 1 2 3 4 5, if we find the mid, so if this 3 is a mid element, so the answer is 3. So we have coins is 3 into mid into 3 plus 1 divided by 2, so the answer is 6. So 6 is equal to 5, 6 is greater than 5, 6 is less than 5, and 6 is greater than 5, so we go left. Okay, because 6 is greater than 5, we go left. Now right is equal to 3 minus 1, it was 2. Okay, so see, now left is 1 and right is 2. Now we find mid, so now mid is 1, mid 1 plus 2 plus 2 minus 1, sorry, 2 minus 1, we find mid. 2 minus 1 divided by 2, so it was 1. So we coins the 1 into 1 plus 1 divided by 2, so the answer is 1. So is 1 is equal to 5, so 1 is less than 5, so we go 5 is greater than 1, so we go right. Okay, so the left is equal to 1 plus 1 2, so the left is 1 plus 1 2. Okay, now see, now left is 2 and right is 2, so we coins 2 into 2 plus 1 divided by 2 3, so 3 is equal to 5, 3 is less than 5, we go right. So now left is 2 plus 1, it becomes 3. So see, now left is 3 and right is 2, so we stop here because left is greater than right, so we stop. Okay, now we return 2, so the answer is 2. It was clear thing now. Okay, let's take one more example. In see, row 1 we have 1 coin. Okay, in row 2 we have 2 coins. In row 3 we have 1 2 3 coins. So we have not completed 3 coins, we have just left 2 coins at last, so the answer is 2. So that's the answer comes 2. Okay, now let's write down the code first. So we need 2 point variables, left is equal to 1 and right is equal to n. Okay, means start row 1, why 1? Because minimum possible row is always 1. Okay, maximum possible row is n, so why n we have take, we can never have more row than coins. Now we make a condition while left is less than or equal to right, means keep searching until I cross right. Okay, we next we find mid is equal to left plus right minus left divided by 2. Find mid row, and this is the row we check right now. Okay, so next in see, now here is an important point. Okay, first let me write with okay, see, first we take int coins is equal to mid into mid plus 1 that divided by 2. Okay, and divided by 2. Next we have to write if coins is equal to n, return mid. Return mid, else if coins is greater than n, left is equal to mid plus 1, move left side, or else right is equal to mid minus 1. In last we just return result yes. So why we have returning R? When root start, R has always point to the last complete row. So it's run. Okay, runtime error, sign integer overflow cannot be represented in type. See, now what's the problem? This look correct, but there is a problem. See, what is the maximum value in can store? Okay, so we cannot use in because it will overflow. Mm, like wait, let me clear in detail. So if in max is equal to like 2 147 and 483 647, like about 2 billions, okay, 2 billion. So what if n is, so see now what is if n is equal to like 100 000 and 000 this billion. So if mid is, we find mid is equal to 500 and 000 okay. So if we into say this mid is into mid plus 1 like 5 5 0 0, and if billion 0 0 0 and one more 0 into 5 0 0 0 0 0 0 and 0 0 1, so the answer will become 250 0 0 0 and 0 so on, okay. So see, this is way bigger than 2 billion, so it cannot store this. So this is called overflow. So the wrong answer will become, so instead of this we use another data type, and that was long 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 long, okay. So see, wait, so here also the problem, let me show you. See, but even this is wrong. So why? Because mid is still in mid. So see, wait, mid is still into, so if mid into mid plus 1, calculate as int first, okay. So overflow happens before the storing in long arm, okay. So the correct way is we have to write like this, long long, okay. So long long will convert mid in mid also long long first, so now multiplication is safe, okay. Now the multiplication is very safe. So now it's works, see, wait. So that's it, sorted. If the range is sorted, if n is going, if n is 5 means it's going like 1 2 3 4 5 sorted range, okay. If it's the sorted range, always think binary search, okay. Next is we have k rows and need is k into k plus 1 divided by 2 coins, okay. So next is see, if there are large numbers, always use long data type, okay, because cars before multiplying we have to convert this also long, okay, long for mid. So see, when loop ends, r is our answer, okay. So the in brute force the time complexity is big of n, but in binary search the time complexity is big of log n, okay. So that's it, hope it was helpful. So see you in the next one.